Sadly, in my lifetime, I think we will see what it really means to have significant ice loss in the Arctic and what those implications are.
В 1906 году в Арктический институт приехал профессор Клаус Детлов, который предложил координировать работы в Арктике на дрейфующих станциях с институтом Альфреда-Вегенера.
19 nations coming together, that's really remarkable. We really are organized under a shared vision.
Given that we were strangers, most of us were strangers to begin with, and at some point we just found a way to trust one another and to rely upon one another, and most importantly to support one another.
MOSAiC ist ja damit wirklich weltweit eine große Ausnahme. So gelingt es uns durch den gewaltigen gemeinsamen Einsatz aller Beteiligten hier und diese Expedition auch unter den ganz schwierigen Bedingungen der Corona-Pandemie fortzuführen.
To feel that, you know, the Arctic science is really going to be in good hands. We've got this whole new crop of young people that are coming up, and MOSAiC is helping to lift them up into this kind of new world of Arctic research as we unravel the puzzles of the changing Arctic system.
Welcome to this talk here at Futurium at MOSAiC Day. We are connected with two leading scientists from the exhibition. Welcome, Julia Schmale. Hello.
Hello.
And Matthew Shupe. Julia, hello.
Hi there.
Oh, it works, the technique. I'm very happy to see you. We are here with a very exquisite audience. They see you, and hopefully you also have questions for these two. Julia Schmale is atmospheric researcher at Paul-Scherrer-Institut. She is leader of the Swiss aerosol project Embrace at the MOSAiC exhibition. And Matthew Shupe is from University of Colorado and is co-coordinator at the exhibition. So welcome here to this talk about One World, One Exhibition. Following the footsteps of Fridtjof Nansen's groundbreaking exhibition 127 years ago, MOSAiC brought a modern research icebreaker, Polarstern, close to the North Pole for a full year, including for the first time in polar winter. Julia Schmale, when you first heard of this exhibition, what did you think?
Yeah, maybe just briefly beforehand, just for the record, I'm at the École Polytechnique Fédérale de Lausanne in Switzerland right now. Science is very dynamic, so I've moved institution.
But as a researcher at the exhibition, you were at the Paul-Scherrer-Institut.
No, actually, it's both institutions. We started off preparing with the Paul-Scherrer-Institut, and we finished everything off with EPFL in Lausanne. So it's a good collaboration.
Very good, thank you.
Yeah, so to answer your question, so the first time I heard about MOSAiC was in 2009, and Matt can correct me if I don't remember correctly. I think there was a meeting in Boulder, which then I actually got an invitation but couldn't go to. I was very sad, but there were other commitments. But then the second time MOSAiC really surfaced on my agenda was in 2013, when we had a meeting in Potsdam, which I could attend and then actually help shaping a little bit of MOSAiC. And I mentioned the first time I was sad that I couldn't participate in 2009 because I was so intrigued by the idea of participating in an expedition that would stay for an entire year in the Arctic and actually open up opportunities to do research, which otherwise we don't have.
Mm-hmm. Matthew Shupe, you mentioned it. It's a collaboration. 30 research institutions from 20 nations of the world. So, what was special about this exhibition, about this collaboration, Matthew?
Well, it really is special to bring so many different nations together and so many different institutions. You know, we all speak our own languages. We brought together many disciplines scientifically. So in many ways, we were different people, but out there in the field, we all work together in such a seamless way, volunteering to support each other's projects, working together to maintain a safe environment, and of course, accomplishing fantastic science. And so to me, you know, I'm used to collaboration. I do that a lot, but this really just took it a whole step further of really showing how complex an expedition can come together in this really seamless and smooth way.
So what was your main interest personally at this exhibition? What did you know, what did you want to know about the behavior of the Arctic system?
Yeah, well, the Arctic system is changing pretty rapidly. We know this. We've known this for some years. But really at its foundation, there are a lot of key processes involved. And this is the part that we don't understand very well. Why is the ice melting so fast? And what does that do to the rest of the system? And that's really the fundamental question that we're addressing with MOSAiC and all the different pieces of MOSAiC. And so that drew me there, and it drew many others there. Me personally, I'm very interested in the energy balance at the surface. So these are all the terms from the atmosphere that come down to the sea ice and affect the sea ice. And so, of course, if you're interested in the changing sea ice and the melting sea ice, you'd want to understand the transfer of energy at the surface. And so that's what I'm looking at myself.
And so what I understood is that clouds, cracks, ice, aerosols, the Arctic climate is your main interest, actually. So how did you do this kind of research?
Well, very comprehensively, I'll say that. We brought all kinds of equipment to look at all aspects of the system. And so for myself individually, I look at clouds, I look at the atmosphere, I look at the surface. And so I brought a suite of instruments, remote sensors. These are things like radars that look up at the atmosphere, and the signals that bounce back tell us about the particles that are there, the clouds, and how much water's in the clouds, and what their radiative effects on the surface are, things like that. So lots of instruments on the surface for looking at the clouds and measuring radiation and measuring other properties. That's mostly my approach, and others had different approaches where they would sample different aspects of the system. For example, take snow samples or ice samples or air samples. And Yulia actually is one of those people that takes air samples, so she can tell you all about that.
Yeah, so Julia is leading or was leading the Swiss or is leading the Swiss aerosol project. So what was your main interest? Aerosols. We know about aerosols now because of Corona, but what kind of aerosols are you interested in?
Yeah, exactly. So Matt already mentioned that they're quite important for the chemical composition of the atmosphere and also influence clouds. And so this was our main research question. Where do they come from and what do they do in the Arctic in terms of Arctic climate change? And maybe to elaborate a little bit, these particles or aerosol particles can come from human emissions or human activities, which is very much the case in the wintertime Arctic. This is when we speak of Arctic haze. So basically the atmosphere is polluted and it's emissions from the mid-latitudes, roughly where we live, that are exported to the Arctic. But then in summer, this changes, so there's not that much transport of the human particles to the Arctic, but there's more natural processes. So in summer, then our focus shifted to understand what are the natural sources of these particles. And this can be sea spray. When you go to the coast, for example, you can feel it on your lips, that it's a bit salty. So that's something we can research, but it's also blowing snow. And then the most intriguing processes are actually when you have microbial activity in the ice, snow, or water, and they emit gases, which then form particles in the atmosphere. And this is what we looked at. And in order to do that, I mean, you can imagine that these processes can be very quick, actually, if you have blowing snow or phytoplankton emitting gases. So we need instrumentation that can respond very quickly, so in the order of seconds or 10 seconds. And to do that, we placed a laboratory container on Polarstern on the bow, and then let the air from the outside into the container with specific tubings and so on, and then analyzed this air in real time with the instrumentation that we brought. And what did you find so far in this Arctic air? A lot of things. So that's it's a difficult question to give a short answer to. But as mentioned, so in winter, when the Arctic atmosphere is quite polluted, we can absolutely confirm that. And you know what is remarkable about it? It's so persistent the whole time. You basically don't see any change. It's like drawing a flat line on your computer screen when you measure these things. And this is something that is very rarely observed in any parts of the Earth and in any other parts of this Earth. And then what was very remarkable and super interesting to see was the transition from winter to springtime or to summer. You know, we had a couple of warm air masses coming from the south, while before and after we had more northerly air masses. And so the air from the south was not only warmer, as you can imagine, and carried more moisture, but also the complete chemistry of the atmosphere changes. And this was within a couple of hours, and nobody would have imagined this to be so quick. So this was actually quite fascinating to see. We see in the background a picture of Polarstern at the Arctic exhibition. And my question is, we see the chimney and the polluted air. How did you avoid to measure this polluted air from the Polarstern? Yeah, essentially you cannot avoid it. Because I mean the engines need to be running to keep us warm, to produce energy, to produce the electricity for all the measurements. So you can't avoid it. But if you have instrumentation that collects data in real time and at very high time resolution, you can basically remove the data where you have the influence from the exhaust. So this is the strategy that we had, because it's very challenging. We knew that beforehand, and so we had to be prepared for this. And this is why we take these data points every second. So every second that is clean we can use, and every second that is not clean that cannot be used. So Matthew, how was your you were responsible for the installation of atmosphere cloud and precipitation, radiation, aerosol measurements. So how did it work? I can't imagine how you measure these elements.
Yeah, I was the leader of a number of projects that had different sets of instrumentation. And so one of them was mostly installed on board the ship with a number of sea containers that were laboratories where we installed equipment. And these instruments were instruments that looked up at the atmosphere or sampled air from the atmosphere. And we had quite a large team of people that actually implemented that facility. And these were instruments that were installed above the bridge of the ship and all over the ship, really just an amazing amount of science. And most of those instruments are what are called remote sensors. So they will either send a signal up into the atmosphere that will reflect off of some property of the atmosphere, like it'll give you information on winds, or it'll give you information on cloud properties or radiation. So there's active sensors that send a signal up and some of the signal comes back and they measure that signal. Or there's passive sensors that just sit there and passively, for example, collect photons from the sun and they measure how much sunlight is coming in. So there's a very extensive suite of instruments like that. And you can imagine that they're very technical and sophisticated. And so the technicians every day would go around and make sure those were running properly, would make them adjustments or fixes when those were necessary, and would do a lot of calibration. Calibration is really essential for our work so that we know that the signal that's coming back actually means something, that it's actually related to a property that we're trying to derive. So that's one area of the research, but we also needed to make a lot of measurements that were away from the ship, that were not influenced by the ship. You mentioned the exhaust for aerosol measurements. That's really important, of course. And there's other influences from the ship, like turbulence. You can imagine the winds that flow over the ship could affect the turbulence. And, we're not so interested in the turbulence over the ship. We're more interested in turbulence over the ice. And so we set up a lot of our installations out on the ice, away from the ship. For example, a lot of my equipment was at a place called Met City. This is the meteorology city. And we had a tower out there, and we had some other equipment set up to look at the properties away from the ship, to really understand how does the lower atmosphere interact with the surface, to understand how does atmospheric radiation reflect off of the sea ice surface back up to space, and many other properties of that kind of energy transfer between the atmosphere and the surface that are away from the influences of the ship.
Mm-hmm. If there are any questions in the audience, feel free to go to the microphone there, and you can have a question for the two of them. So you're invited. You saw significant ice loss at the Arctic at this exhibition. So what does this mean?
Well, it means that the Arctic is in a state of transition. And I think that we all know that, right? We know that the Earth system is changing, and the Arctic is really leading the way, right? The changes that are happening in the Arctic are more extreme than elsewhere on the globe. That's true in terms of temperature change, right? The temperature change there is at least twice as much as the temperature change in the rest of the globe. And a lot of that is because of this melting ice. And this is such an important part of the Earth system, right? Ice is very reflective. You see in the picture behind Julia there, it's all white. That means it's reflecting all the sunlight back to space. And that's kind of decreasing the amount of energy that's absorbed by the Earth. But as that ice melts, it exposes more ocean, which is very dark and absorbs a lot of heat. And so relatively more sunlight is absorbed by that dark ocean, which really amplifies the signal, right? So as we get a little bit of warming, we get more ice melting and more absorption of energy, which leads to more warming. And this is a feedback that really amplifies this climate change. And so the Arctic plays this really important role in the whole global system, and it's leading the way in climate change.
So when the Arctic is the key area for global climate change, how can you help with your research data to investigate this change?
Well, we really have to understand the role of the Arctic in the global system. There's a lot of questions about that. How does Arctic change affect us back home? These are questions that we don't really know the answers for, and that we're actually very much curious about those answers, and how do they influence our weather, for example, or how they affect our ecosystems. It's important for us to understand these things, and really the best way to do that is to have models that can represent the Earth system. Right now we have these global models, and they've largely been developed based on data that's taken elsewhere in the globe. Right? We have all kinds of measurements in Europe or in North America or in places where there's a lot of people, and so we've built our models based on those kinds of observations. But we have relatively few observations from the central Arctic because it's very hard to get there, and especially like the Arctic winter, where we were just there for MOSAiC. So we need to get these data, these observations from the Arctic, so that we can create models that represent the Arctic in a real true way, an accurate way, so that we can then have models that will tell us the answer to our questions about how does that changing Arctic affect our climate as we go forward here for the rest of the globe. So that's kind of the foundation of MOSAiC, is to go get that data so we can improve those models and then improve our larger scale understanding.
So you were measuring and monitoring the sea ice throughout the entire annual cycle. What changes did you see during this year of exhibition?
Yeah, the sea ice is extraordinary. It is so cool to be there. And each season has its own character. Right? I started out going out there at the beginning of the expedition, and we went out and it was getting dark, right? The winter was coming, and the ice was getting thicker, and the snow was falling on the ice and creating this kind of eerie landscape with the snow blowing around, and it's very dark. And at that time of year, well, everything freezes. So if there's a crack in the ice, there's some water briefly, but then it freezes very quickly. And this freezing process is so important, right? This is when the ice is getting thicker and thicker into wintertime. And then as we transition towards the spring, of course, the sun comes out, all the energy budget changes, right? There's more energy coming into the surface. And eventually we get to the point where the energy budget turns around and we lead to the melt season. And this is, again, very fascinating. First, the snow melts on top of the ice and it forms these ponds on top of the ice. So that's really neat to see that evolve. And the ice itself actually takes on all of these different forms. I was just amazed out there by each day you'd look at a different formation, a different crystal structure on the surface. There were days when I would just dig my hands in the ground and it was like I was holding a bunch of jewels in my hands, these little faceted crystals that were really amazing to look at. And then the next day there would be these shards of ice that were all kind of growing together in packages. Just really fascinating ice structures as the ice is melting and the water is draining through it down into the ocean. And so we've tracked that all the way through until the end of the melt season when we had the thinnest ice. And then we were really interested in, okay, how do we get back to that freeze up? And so we saw then all these melt ponds on top of the ice start to form little layers of ice on top of them and start to form all these different crystal structures again and moving again towards the fall and the winter freeze up. So each time of year has its own important characteristics. And we have to understand all of those together. And that's kind of why we wanted to be there for a full year, so that we could connect the dots across the whole year of how these processes are interacting, so that ultimately tells us about the full life cycle of the sea ice.
There's a question for you.
And the mic is not working, is it? Yeah, it is.
Is it working,
Sure.
the mic?
No.
Yes? No?
Okay.
I can hear
Maybe
something.
this one. Okay,
that's
then
kind of
I take
quiet.
a little
So maybe
one.
if you could repeat the question, that would be great.
Yes.
The children's microphone. We had the children's talk before with really interesting questions.
Okay, then I go with that one. So my name is Elisa, and it's really interesting to hear about the research you did and also the really intriguing experiences that you made. And I'm just wondering, since you're apparently living in the US and in Switzerland, how your experiences and how the expedition is perceived in your countries. Is there a big publicity about it, or is it very recognized in the research community, in the political community? Because especially in the US, from here in Europe, we take it's a very controversial topic because not everyone will be likely to following you that deep into your research results and the relevance of the measurements that you're taking there.
Yeah, that's a great question. And I think there are multiple answers to that question. I mean, in the US, of course, where I'm from, climate is such a crazy topic right now. We have such differing opinions about climate change even. Is it real? Which to me is an odd question to ask, because certainly it is. But then also the big question about what we do about that. And, as a scientist, I'm really dedicated to collecting the information, right? In the end, we need solid information to make the choices that we need to make in society. And those choices, in my opinion, are made by many other people. It's made by all of us together, but we need to make those choices based on good information. And so as a scientist, that's what I'm trying to do, is get that information. Now, in the US, there is certainly some publicity about MOSAiC and about the activities that have gone on there. Later today, I'm giving a presentation to a large government body that is very interested in the results. And so, yeah, there's a lot of interest. I think there could be more. Right, I think there could be more interest, and that's partly why activities like this today are so important for reaching out to a broader society, so that people can understand what we do, why we do it, what we're finding there, and what that means for everybody back home. Because I think it really does matter back to everybody at their home, and in Germany there, or in the US or many other countries. It matters to us what's happening in the Arctic, but most of us will never get a chance to go there. And so it's important for the scientists to be able to interact with society to help to kind of bridge that gap and to explain the importance of what's happening there.
Julia Schmale, can you tell us something about the reception in Switzerland?
Yeah, sure. I think it's a really good question. And so I think in Switzerland, the situation is a bit simpler or easier, if you want, compared to larger countries. Because if there is such a big expedition like MOSAiC, this naturally can make the news much easier than in larger countries. So in terms of outreach, I think it's relatively easy for us to reach the general public. So when MOSAiC started last year, or when we came back last week, it made the main news in the evening. I mean, you cannot have a better platform for that. So this is actually fantastic. And I think part of the reason why that is possible here is actually the local geography. Switzerland is dominated by the Alps, and there is glaciers on the mountains, and the glaciers undergo a similar fate as the Arctic sea ice. They are melting away, and people see that. I mean, people here like to spend their time outdoors. They go a lot to the mountains, and you don't need to be 60 years old to have seen changes. You can see that when you're 20, for example, because there was so much change in the last 10 years. So the population is actually very sensitive to these topics, because there is an immediate impact here in the country regarding water resources, which is energy and drinking water, or also for agriculture. So from that perspective, it's relatively easy to get the message across and tell what we're doing, also why we're doing that, and why it's necessary to have such a big investment into Arctic research. And maybe one small addition, so there is something called the Arctic Council. So these are the 8 nations that border the Arctic, and there can be observers. And Switzerland has applied to be an observer a couple of years ago, and then you run something like a political campaign also to become an observer. And what our Ministry for Foreign Affairs then had as a slogan was that Switzerland is like a vertical Arctic nation. The ice is not on the ground, but it's more up in the sky here. And I think that resonated quite well. And so I think for us, it's a really good topic that's very relevant to the local population as well.
Well, thank you very much. Here's another question from the audience.
Yes, good afternoon or hello. My question is, I understand that you study different topics. On the one hand, the energy balance, on the other hand, the aerosols. And can you give some insights from your research how these two interact? Because I think aerosols certainly influence the energy balance. So what did you find about that? And considering your research, what would be your suggestion to us? So if we just remove the dirt from the air, which would reduce the aerosols, would this help? Would this stop the cycle? Or what insights can you give?
Yeah, that's a very complex question. Thank you. So maybe the first part of the question, how the aerosols and the energy balance are connected. So if you look at the aerosols particles in the atmosphere, then they can have 2 main effects on climate. So they can interact with the solar radiation directly, so they can scatter the sunlight, or they can also absorb the sunlight. If they absorb, this leads to a local warming, and if they scatter, then this can have a cooling effect. But there's another effect which we call an indirect effect, or the aerosol cloud interaction effect. So actually clouds can only form because there are aerosol particles in the air. Otherwise the droplets would not form or nucleate, as we say. And so you need the aerosol particles to form clouds. And then of course if you have a cloud in your atmosphere or in your system, then the cloud will reflect sunlight, but it will also reflect the warm radiation from Earth. So clouds can have both a cooling and a warming effect. And in the Arctic, in wintertime, for example, when it's dark, you don't have the solar radiation, but you still have the warm terrestrial radiation. And then if clouds are present, then they can reflect the warm radiation. So they really act like a blanket in that case. And there is many facets, as you can imagine, because in summer, for example, when you have less sea ice and you have the dark ocean, and Matt already talked about it, that when the sea ice melts, you have more dark surface that absorbs more radiation, and then is a positive climate feedback. If you have clouds in that equation, then the clouds would reflect most of the sunlight before it can actually reach the warm ocean. So this is very important. And so you said we're studying different things, but maybe, yes, in the details we might be studying different things. We use different instrumentation, but in the end we actually study two very important elements of the energy balance system, the aerosols and the clouds, and then the energy fluxes themselves. And yeah, maybe I let Matt answer here, and then if you wanted to come back into what we can do to mitigate the situation, we can discuss as well.
Yeah. First, I would be interested in Matthew Shupe's answer about your collaboration.
Yeah, I mean, it's essential. Yulia did an awesome job of describing some of the interactions and processes. And so I don't have a lot to add to that. I mean, from a kind of physics standpoint, aerosols and clouds are so intertwined and so important. And I will add, I guess, that these two areas, right, aerosol particles in the atmosphere and the clouds that form, are two of the most important factors in our climate system and most uncertain in our models, right? So we're trying to forecast what's happening in an Earth system and predict our climate in the future. And some of the biggest uncertainties are related to those kinds of processes, clouds and aerosols. We just don't even know, right? Some of the feedbacks that Yulia talked about, are those positive feedbacks or negative feedbacks? Because during certain times of the year, maybe they're positive. At other times of the year, maybe they're negative. And so how does this whole complex system come together and ultimately tell us about how the Arctic system is changing and how that is feeding back in a positive way or a negative way on our climate system? So the work that we're doing there is super essential, right? Understanding the sources of aerosol, where they're coming from, where they're going, understanding how they interact with clouds, understanding mixed phase clouds, which are clouds that are composed of liquid water and ice water at the same time. Things like this are, this is really the cutting edge of science, and one of the important reasons that we're there, doing these studies together so we can understand these interactions and then represent them in our models.
So back to you, Julia Schmale. What can we do?
Yeah, that's a huge question, and it's actually not easy to answer because the answer is potentially confusing. So if we think about it, the aerosol particles are needed to form clouds. So we will want some in the atmosphere because clouds are hugely important because they also produce water. But there is lots of different sources of particles. So there is natural ones like the sea spray we talked about, but I mean there is also the mineral dust from the deserts or the soil, and many other sources. But there is also the human-made particles, and those we're probably more familiar with in the context of air pollution. So if you think about your options, what you can do, I think reducing the particulate matter or aerosols that we emit through road transport, industry, agriculture, you name it, then it's a good thing because we will reduce the health impacts. And of course, we can already see these impacts also in the Arctic from the air quality policies. We have long-term observatories, which are basically complementary to what MOSAiC did. So MOSAiC went for an entire year. We went to a location which where you cannot have a land-based long-term observatory, clearly. And also in MOSAiC, we investigated many processes with cutting-edge instrumentation, which a long-term observatory cannot do. So imagine you had 5 MOSAiCs all the time ongoing. That's impossible. It's too much workload. But there is other observatories around the Arctic that measure more routine or basic aerosol parameters. And there, if you look at what we measured in Svalbard in the European Arctic, or in the North American Arctic in Alaska and in Canada, we see that from the 70s, basically, the pollution indicators like soot or also sulfate, acid rain was a big topic in the 70s and 80s, then we see that they all decrease. And this is a really good thing to see, because we see that the human-made pollution that is reaching the Arctic in winter and springtime is actually going down. So this is probably part of the answer that I can give you. And then to understand the nitty-gritty detail of how more clouds or less clouds in the Arctic will accelerate or decelerate climate change in the Arctic. This is why we were there, to actually figure out, because as Matt said before, the models are not there yet. So we need to improve the models first. And then we can run these model simulations to understand, because it's something we cannot easily directly measure. And we would need to measure much longer than the duration of MOSAiC. So this is something we'll find out in the future. But just to come back to my first statement, I think reducing the human emissions, it's basically a no-brainer. It's good for health, it's good for the environment, and it's just a sustainable measure.
You brought back from your exhibition tons of data. What are you doing now with all these data? Or what is the most interesting measurement you made? Julia?
Well, I can answer that one. I guess that, the data is really the legacy for MOSAiC, right? We did all of this so that we could come home with this data. It is so valuable. And it's really a gift to the global community. It's a gift to the research community and everybody else to really understand the Arctic system. So now we have this huge pile of data, right? An unprecedented amount of data. And now that data is being injected into the research community. So, my own institution, Julia's institution, many others now have all this data, and now it's time to figure out what it means, right? We took the measurements for a reason. We designed this expedition, but now we actually have to do the analysis. We have to understand what the data is telling us. And so, for me personally, my favorite measurements are radiation at the surface, right? I think radiation is the foundation of our global system. And so if you want to understand the sea ice, you have to understand the radiation. And so I've got a number of different time series, like Julia talked about, these measurements over the whole year at high resolution of radiation. So how much heat is being trapped by the clouds, how much sunlight comes in, how is light reflecting off of the surface, all these different components of the radiation. And I want to look at how that balances. How do the different processes in the atmosphere, like clouds, do they have a net effect of warming the surface or cooling the surface? And how does that change as the seasons evolve? And so those are the kinds of analyses that I'm personally starting to dig into with very long data sets to understand those kind of processes. And then ultimately to start to hand that knowledge off to other collaborators so that we can start to connect the dots. We can say, hey, my radiation balance, how does that relate to your aerosol properties or your cloud properties? And how can we start to put those pieces together to then kind of build bigger knowledge that we can then incorporate in our models?
And is there any hope as a scientist that all these measurements and all the data you brought back from the exhibition can help to change behavior and of all of us and of policy? What do you think?
I think it's a very long way from collecting the data and then changing behavior. I think with MOSAiC, we've had quite a bit of outreach already. So there's many people who know about it, who understand why we're doing that and why it's important. So this, I think, already brings us a step ahead of some other research endeavors. From that perspective, I think it's we have a really good foundation to have this sort of impact. But there is so many more steps involved now. Matt described how we're going to analyze the data, how we make it fit together between the different projects that were on board. That's a relatively long process. So it's going to take a couple of years until we can make deeper sense of what we collected. And then it's not we have a data package and we throw the ball over the wall, somebody will catch it and change their behavior. So we need intermediate or mediators in between who can help us translate what we find into what society can actually do. And scientists are not necessarily experts in doing such translation between what the scientific data say and what society can do. And there is policymakers. I mean, if we think about air quality legislation, this would be one way to reduce emissions, for example. But there is so many other ways how society can change. And of course, some things are possible, some are not possible. There will be many different opinions. So that moves down the road of a political process. And this is where it's very important that at the beginning of this chain, where we are with our expedition and the data analyses, that we make sure we hand over our knowledge to people in the more public sphere, but not only hand it over and then say goodbye and this is it and we do the next expedition, but that we stay invested, that we have frequent or regular meetings with those people who can translate our messages much better to society. And this is where this collaboration between science and the public policy and the outreach communication people is hugely important. And I think the MOSAiC expedition has realized this from the very beginning. So I think we're really hitting the ground running in that respect.
Yeah, because I think you help us very much to understand what you were doing there. And you had a whole film team on the Polarstern that were with you all year. And the film will be aired at German public station ARD im Ersten at 16th of November. We can see how you work and what you experience at this MOSAiC exhibition. So thank you for helping us, being with you as a researcher. We have another question here from the audience.
Yes. Hi, Julia and Matthew. I'm Karen, science journalist from Berlin. Thank you for this extremely beautiful transnational, also transdisciplinary project. What I'd be interested in, you said you have so many data, I think terabytes and terabytes of data. Actually, as for collaborations, would this be would you put all these data like in an open access possibility mode or some platform? So actually every interested research institution, maybe even from research areas you don't think of yet, could have a look at? How do you share this information sooner or later, or do you have a plan already how to share this raw data?
I think I can speak to that. It was very quiet, so I'm not sure I caught all of the question, but I believe that you're talking about the data and how it will be available to a broad community.
Yeah, and in an open source system, probably. Could you put it in an open source system? And so probably how can you manage to continue the collaboration of this international team?
Yeah, and so for MOSAiC, of course, the data is very important. And we have a data policy that all of the participants signed that policy, and we all agree to that. And that data policy does give the core scientists, the consortium of scientists, a little bit of time to work with their data, right? You can imagine that brand new data coming from the field might have some complexities. We have to work on calibrations. We have to work on quality assurance. Like Yulia mentioned, we have to filter out the times when the aerosol samplers are measuring the exhaust from the ship so that we're not interpreting those incorrectly, right? So there's a lot of work that we have to do with the data. And so there is a short period of time in the coming years where we're going to focus on ensuring the high quality of that data. But then within a couple of years, all MOSAiC data is required to be available in public archives for anybody to use. And so at the very most, within 2 years, all of the data will be available for anybody. And we encourage all the individual data providers, such as myself and Julia, to make our data public even earlier than that. And in some cases, the data, for example, that I'm involved in from some of my projects is already available online for anybody to use. And we encourage very much for people to use that. And so this policy, I think, is a nice balance between ensuring the quality of the data that we provide to the public and getting that data to the public very quickly. Because in the end, MOSAiC is much more than Julia or myself or the participants that went to the field, right? This is a gift for all of society that we all need to use. And so we're very much focused on that, providing this data to a broad public audience in a very high quality form.
Thank you. I hope the questions are answered now. So thank you very much. We have no time left actually, but thank you very much for sharing your data and your experience with us. I think it's very important that you tell the public about your experience and your research. So thank you very much to Julia Schmale from the vertical Arctic nation Switzerland. Applause for you. And Matthew Shupe from University of Colorado. And here at Futurium, there's the next talk with Markus Rex, the exhibition leader, and he will tell you about his experience and his research and the exhibition at 7 o'clock. So stay tuned. Thank you very much.
Thank you.
Thank you.